Okay, let's talk ancient astronomy. The pirates used to use stars to navigate. I'm sure you've heard about that before. But it's not only the pirates, but also Arabs, the Vikings, the Indians, Greeks, the Romans. So many communities use the stars to navigate. We call that celestial navigation. In the modern world, we use satellites to navigate. And satellites come with three main problems. They're prone to space debris, cyber attacks, and even signal interference. But fortunately, we can actually create a ground-based solution using AI and celestial navigation, because ultimately celestial navigation requires tedious calculations and we can automate that using AI. The first step would be to classify the constellations. I tried using image classification, didn't work. I tried many other algorithms, machine learning algorithms, until it was only the k-nearest neighbors algorithm that worked. Here's why. Imagine the Cartesian plane. To classify something in the k-nearest neighbors algorithm, you look at the nearest neighbors to a specific point. Now, in terms of constellation classification, this would be the pixel coordinates of each star. An image of a constellation usually has a lot of extra features that we don't want. So we need to apply pre-processing to isolate just the stars and then use an algorithm to find the pixel coordinates of each star in the image. Then we input these pixel coordinates into the k-nearest neighbors algorithm to classify what constellation we're looking at. Since the zodiac constellations are visible in the northern hemisphere and the southern hemisphere, we limit the k-nearest neighbors algorithm to only two constellations, which are the zodiac constellations. Now that we've classified the constellation, all we need to do is find the altitude and azimuth of the constellation with respect to the observer. Now with all that information, all we have to do is a lot of tedious calculations, which is easily automated because it's all code. I call this project Ah-zhun. You can check out the GitHub link below with the entire source code, and even better, you can follow me on Twitter or subscribe to my monthly newsletter. But you know what's even better?